What's up, everybody? Moving on to another question, another communication type of question. What is the solution to this inequality below without using algebra or graphing? So, polynomial inequality, usually what we're doing, bringing everything over to one side, simplifying, then graphing it, or using a sign chart. We're not allowed to do any of that now. So we have to kind of look at it visually. And if you notice, there's a bunch of things we can compare here, because notice how the degrees line up. This is a degree of 4, the first term. And then the first term on this side has a degree of 4. This has a degree of 2, this has a degree of 2, this is a constant, this is a constant. And we have to find the solution for when this expression is less than this expression. Okay, well, let's just compare the respective degrees and their leading coefficients. So we got this 4x to the power of 4, and then we got this 5x to the power of 4 on the right side. Well, notice that this expression is always going to be less than or equal to this expression, right? Because no matter what we plug in for x, this x to the power of 4 portion is going to be the same for both sides. And then we're going to be multiplying this side by 4 and then this side by 5. So this side will always be greater than this side. The only time they can be equal is if x is 0. Because if we plug in 0 for x here, 0 for x here, both sides will be 0. But other than that, this will always be less than this here, because we're multiplying the same value in these square brackets by a lower constant, right? What about the next term? So 6x squared less than or equal to 8x squared. Same thing, because this x squared and this x squared are always going to be the same no matter what x values you plug in. So obviously multiplying that same expression by a lower number, this will always be less than or equal to this, right? 6 is less than 8. Now again, they can be equal when that x value is 0. And then notice this 10 is always going to be less than the 12, right? So if we combine all of these, if we add all of them up, you can tell that this side is always going to be less than this side, because even if we plug in values of 0 for x, where this expression and this one is equal and this one are equal, we'll still be left with a 10 and a 12, right? And the 10 is always less than 12. And then any other x value we plug in, this side, when we add it all up together, will always be less than this side, because each of these expressions on the left are less than the respective expressions on the right. So the answer to this question is actually all x values, right? So there is an infinite. You can either write infinite as well, infinite solutions. If you want to show this maybe in interval notation, we can say that x can be anything from negative infinity to positive infinity, or we can show it in set notation, that x is an element of, actually we could just write real numbers, right? X can be anything. Another way to show that is x is an element from negative infinity to positive infinity, right? So the solution to this inequality, just by visually comparing the terms to each other, so taking the terms with the same exponents, comparing them directly, we can tell that this side on the left is always going to be less than this side on the right. Hence, no matter what x values we plug in, it's always going to work, so it has an infinite number of solutions. Basically, x can be anything.